Hello everyone, welcome back to Geeks for Geeks. I hope all of you are doing well. So today in this live we will discuss the post contest analysis of Biwizard School Coding Tournament 5.0. So just a confirmation from your side that I am audible so that we can start. Of the MCQ problems, and then we will discuss the two coding problems which we have. Okay, in case in case if you will have any doubt in any problem, you can just ask, and also if there will be any problem in my voice or in the screen, you can just tell me in the comment box. Okay, fine. So first let's start with the quiz part. Okay, now we will start with the quiz part of the contest. Okay, so there were 20 quiz problems. Okay, we will discuss each and every problems one by one, and we will just check that how we can solve and what are the correct answers of that given problems. Okay, so this is the first problem, which is that you are given with a one dimensional array. Okay, which is as a from -10 to 5. Okay, so this -10 to 5 is basically telling us the range and the size of this one dimensional array. Okay, assuming that each integer takes one word, where word size is 64 bits, so you are given with the word size 2, and that array is stored in a byte addressable memory, and the first element of the array is stored at location 200. So basically you are also given with the base address. So this MCQ was little it's straightforward, where it is just asking that what is the address for this element a minus 1. This is what is asked in this given problem. Okay, fine. Okay, great guys. Yeah, no, the problem is not wrong. Okay, the problem is not wrong, and we will just discuss the answer of this given MCQ. Okay, fine guys, fine. Yeah, okay, yeah. So for this given MCQ, our answer is 776. Okay, and for that you can just use the formula which we basically use to find the address of a given element in an array. That is the formula which is I hope is understood by everyone how we can use that formula, because our base address is given, our memory of our word size is given, which is 64 bits. So I hope that all things are given. So now you can do that thing to implement, to check that how we can find that. Okay, so for this the answer will be 776. Okay, this will be the answer. If we talk about the second problem, so second problem is bit of a, you can say, a recursive problem. Okay, in this recursive problem you are given with the input a and the input b, so that a and b value is also given. Okay, this a and b value is also given. Just a minute guys. Okay, yeah, so this a and b is also given to you, so you can just apply, you can just make a brute force approach. Okay, and then we can just go through that if a is less than b, then this is the first, it will again call the function, but this time for b comma a. Okay, this is the case. And if till b is not equal to 0, if b is not equal to 0, till then what we will do, we will just recursively call the function in this way. Okay, So this is what it is doing. This is what it is doing. This is the whole code which is given to here. So the thing is that if a is less than b, then it will just call the function for b comma a. And if b is less than a, if b is less than a, okay, getting, if b is less than a, then only the pointer will come here. And if b is less than a, also b is not equal to 0. In that case, we will again recursively call for a comma b minus 1. And if there is a case that if b is less than a, okay, because if b is less than a, this will also false. If b will be equal to 0, then this will also false, and this return 1 will be there. So this will be the basic normal recursive approach what we can apply here. This is what we can easily apply here, and that will be the answer. So the answer for this problem is 256. So 256 is the correct answer for this MCQ. Okay. So please check, guys. If you have any doubt, you can just ask me, and then we can move towards the next MCQ. Okay, fine. Now for the third thing, what will be the output of the following pseudocode? So this is the code given to us where the value of a is 3, value of b is 41, and value of c is 7. So guys, I just want the answer of this from your side. So as you can see that we have not changed the value of a in these operations. So the value of a will be 3 only. Can anyone tell me that what will be the value of b after this line will be got, which is b is equal to b mod 4? What will be the value of b after this? Can anyone tell me? Because the value of b is 41 and we are taking mod of 4 with it, okay, so 41 mod 4 will give us 1 only. So that's why the value of b will become 1. Fine. Yeah, you can ask your doubt, Sirin. You can ask your doubt. And similarly, when we will find the XOR of a XOR c XOR a, you can just simply find it. And also here in this case, there is no need to take a 2 times, because the value of a XOR a is a itself. Okay. Yeah, this symbol is basically, this is a XOR symbol. It is a bitwise XOR symbol. I hope that you all have learned about that. It is a bitwise XOR symbol. Okay, this is what we have to do. So now after implementing this, the final output will be a XOR c. So a XOR c will basically tell you a is 3 and c is 7. So the value of a XOR c will be 5. The value of b will become 1 and the value of a will be 3. Getting? Is this clear, guys? Is this clear, guys? So basically here it will be when we will make this a XOR c. So c is 7 and this a XOR c means 3 mod 7. So 7 is, if I will just open a whiteboard and if I will just try to explain this thing to there, explain this thing to you guys there in the whiteboard, then just let me share that. Okay, just a minute, guys. Okay, yeah. Okay, great, guys. Okay, yeah. So the thing is that our value of a is, okay, a value of a was 3. Okay, our value b was 41. Okay, and the value for c was 7. So when we will do, this is 7. Okay, this is 7. I hope everyone knows this, and this is 3. Okay, getting? So the thing is that when we will, so we have to find a value of a XOR c and then XOR a. So basically the value of a XOR a is 0. This is a property of XOR. So because we are taking this a XOR a, it will be cancelled. and at the last C will become C only. That is the beauty of this problem. That is the beauty of this problem. That C will become C only. Okay, fine. If you will just do it manually also, then also you can see that after doing this step, the problem will become this, and then again making it XOR with A, it will be 1 1 1. Okay, great, great. So now this is the thing which we were doing. I hope you all have got this. Okay, so now let's move towards the problem, the quiz section again. Okay, great, great. Okay, guys. So here our C will be 7 only, our A will be 3 only, and our B will become 1. So the total sum will be 11. Okay, great. Now the next problem. So the next problem was again a good one, okay, in which you have to first find the length of this string. So length of this string is simply, you can say that it is 13, okay, and then you have to take the XOR of 13 with 3. So after taking the XOR of 13 with 3, we have to take the XOR of 13 with 3, okay, so it will give something 14. The XOR of 13 and 3 is 14, you can just check it. So the answer will be this only, because we have to represent that number in binary form, decimal form, and hexadecimal form. Okay, so this is how we represent 14 in binary, this is in decimal, and this is how we represent 14 in hexadecimal form. Okay, now for the next part. So this was a problem which you have to just make a simple solution. You have to just count, you have to just make some calculations, some basic calculations should be done by you to find the answer of this problem. Okay, and you can just use your left shift operator. I hope that you all have knowledge of the left shift and right shift operators. Okay, you can just use this, and the final answer of for this particular problem will be 16. Okay, so this is the final answer for this problem. Aditi, your coding questions were not opening. Maybe there was some problem on your side, because as many of you were attending the contest, so none of the others have got this problem. So maybe there was a problem from your side, Aditi. Okay, no problem, fine. Okay, yeah, so this is for this fifth one. Now for the sixth one, again you can say that the value of I is given to you and the value of j is given to you. So I is 16 and j is 32. Okay, now what we have to do is that here first we have to find the value of I or j, and then we have to, there is an AND operator, and then there is j or I. So if we will just solve it using the property of bitwise operators, how basically the bitwise operators work, I hope that you all have learned about the bitwise operators, the XOR operator, OR operator, AND operator, then it is a clear for you guys that how can we solve this particular problem. It will be very clear to you. Just like you can see here, that here it is I XOR j. So as we have already discussed that how we can find the value of I, A XOR B in the previous XOR problem. Okay, so this is how you can just find the answer for this particular given problem. Okay, and the right answer for this problem will be this one, which is 48,1,48,0,0. This is the correct answer for this problem. Okay, great, great guys. So this is how we can just simply solve this given problems. Okay, fine. I hope you all are getting this. Okay, now for the seventh one, for this seventh, it is like again this is a for direct forward question for right shift operator and left shift operator. Okay, where you have to just apply the right shift and left shift operators. Fine. So as we all know that when we apply the left shift operator, the number is multiplied by 2 if we apply left shift operator once. Okay, and if we apply right shift operator, the number is divided by 2. Okay, so this is what happened to us. Okay, this is what has happened. Fine. Okay, fine. Okay guys, so I hope that everything is clear to you all till now. Okay, yeah, if we talk about the answer of this, the answer will be this only. Okay, this will be the answer for this given problem. Okay, for this given question, this is the output. You can just simply use the property of right shift and left shift operators, and you can just find the value for this. Okay, great, great. Now here again, guys, the thing is that here we have the unary operators, just like in this increment operator, and this type of logical or and logical and operators are given here. There is a XOR also. So again, this is a pure arithmetic type of expression, okay, where we have given with the proper values of a, b, c and d, and then we have to update the values of these, and then we have to store that in a variable d only, okay, and then we have to just output the values of a, b, c, d. So if you will see, there are the values of all the variables are changing basically, okay, the values of all the variables are changing basically, okay. So this is what is given to you. Fine. So if you can see that the first answer for all the option is 11 only, so that means that pehle ka to 11 hai, the first will be 11, okay. So this is how you can just solve it. And if I talk about the answer for this problem, so the answer will be this one, which is 11 minus 8, 0 and 1, okay. You can just check out this problem, okay, how we are doing it. So it is something like we can just first check for b, check for a, check for c, and using that values of, we can just find the value of d. This is how you can simply find this problem, okay. Great, great, guys. Fine. I hope that this was easiest problem, okay. Here we have just we have to check that this parenthesis pattern is valid or it is not valid, okay. Is it valid? So it is a balanced pattern, because you can just see that all the brackets are of similar type. So in that case, when all the brackets are of similar type, then you have to first check that all the closing brackets are equal to the opening brackets, and there will not be a case that if we start from the left side, then closing brackets are more than opening brackets, because if a bracket is opening, then only it can be closed. So the answer for this is balanced, because this particular sequence is balanced, okay. Now, okay, this was a pretty tricky, because the thing is that you are asked with the in order traversal of this tree, okay, and you are given with the pre-order traversal and post-order traversal of a tree. The thing is that to find in-order traversal, pre-order and post-order are not required. Why? Because basically the in-order traversal of a tree is, if we sort all the nodes of the tree, then it will give us the in-order traversal. Simply we can check that which of these arrays sorted. Okay, we can just simply check that thing, and you can see that this particular given array is sorted. This node set of nodes is sorted. So this will be the answer of our problem, okay. Great, guys, great. Now it is like that, what is the in which of the following conditions the quick sort algorithm gives worst case time complexity. So this is a quite of theory based problem, okay, you have to check also. So the thing is that in which case it will give the worst case complexity, okay. Yeah. Guys, if anyone has any doubt in till now, you can just ask, okay, you can just ask in the fine. Fine. Yeah, we are just moving towards the coding problems. Just a minute. Yeah. So if the thing is that if the array is already sorted, in that case, the our quick sort algorithm gives the worst case time complexity. Okay. This is the case for the quick sort algorithm. Fine. Next problem. We have to just identify the type of casting. It is a direct problem which is asked. I hope that you all have got that the answer will be explicit type casting, because we are taking here the integer that we have to take the data type. Okay, fine. Suppose each of push and pop operation on stack takes 1 unit of time, and insert and delete operation takes 2 units of time. Okay, so a push pop 1 unit and insert delete 2 units of time. Assuming n elements are in the stack, find minimum time to reverse the elements in a stack using queue. So this is something which we have to find the minimum time required to reverse the element in the stack. Okay, to reverse the elements of the stack. Fine. Yeah. So if we talk about because there are n elements, okay, because there are n elements, so what we have to do is, so for each element first we have to, pop it, and while popping we have to also take it in another stack, okay. So and also we have to delete it, okay. Then we have to insert it again, which is using the push operation, okay. So obviously what we will do, that first, because to reverse a stack, what we do, we will store it basically in a queue, okay. So first we will pop it, that will take 1 unit of time. Then we will insert it, it will take 2 units of time. Then we will again delete it, it will again take 2 units of time. And then we will again push it into the stack, so it will take again 1 unit of time. So total it is taking 6 units of time for each element to be, first it is popped, then inserted, then deleted, then pushed. So basically it is taking 6 units of time for each character. So total it will be 6 into n. That is the answer, okay. Great. Now for next one, the below array denotes a road of 160 kilometers. Each cell denotes 10 kilometers. At the beginning of every cell, there is a fuel station, okay, where the rate of fuel is the number written inside the cell, which is coins per, it is the rate of the fuel. Each fuel station has an unlimited amount of fuel, okay. Each has, आप कितना भी fuel fill करा सकते हो. You have a car which runs 1 kilometer per hour and it has capacity of 200 liters. Initially, your car has no fuel. You are at the beginning of the road and you reach to the end of the road. What is the minimum number of coins you need to spend on a fuel to cross the road? So this is somehow of a greedy problem, okay. The greedy means that you have to just check that what is the amount of fuel which is required, okay, by a person to be filled in the car, okay. So in this problem, if we talk about the answer is 780. You can just solve this problem. The way how we will solve this problem is that here you can see just a minute, this number written inside this cell denotes the coins, okay, the rate of the fuel. Fine. So obviously the thing is that if we have to, for example, if we are starting from here, okay, we are starting from here, the first cell, okay. So if this first cell is basically 16 and the next cell is 21, so the price of this first station is less than 21 and the price of this 4 is even less than 16 and 21. So obviously we will try that we will fill the fuel in our car from this third station only, because it is the minimum one, okay. So that is what we will try. We will just go on a greedy technique. You can just solve it using observations and implementations, and answer for it is 870, which we can just solve it, okay. Because at a time only 200 liters of fuel can be taken, okay. So because this is the station, this third station has the minimum price coins per liter, so we will try that यहाँ से हम लोग we can fill maximum amount of fuel from this particular station because it is taking less. Fine. So this is how we will do. So first from here, from this 16th means the first station, we will just fill that much of fuel, okay. We'll just fill that much of fuel that we can reach 4. Then from 4 we will fill the fuel so that we can reach the next one, and then for the again minimum number of fuel, okay. For this given, you can see that this is the given string to you, okay, and the frequency of each character is like this. Fine. We have to decode the given Huffman code. So this is the Huffman code given to us, and using this code you have to find that what is the you have to basically decode this Huffman code, okay. You have to decode this Huffman code. So I hope that this is a straightforward question that you are just given with the is also given, frequency of each character is also given, so you can just do it like that. We can just make a Huffman coding method, and we can find that for each given code what will be the corresponding character, okay. So for this you can see that it is that the answer will be BEDA. This is basically the answer for this given code, okay, for this given code, this Huffman code. This is basically the heap sort way of problem where we have to given the max heap. We have to consider tree. The node 23 violates the max heap property. Once heaply procedure is applied to it, what position it will get. So basically here the node 23, which is this one, is violating. Why? Because our node should always be greater than its children. But you can see 23 is less than, is this 23 is less than this 45 and this 45. So basically this 23 should not be at this place. So this 23 should be at this place 9, and this 29 should be at this place 4. That can be a possible way. Okay. So if we talk about the correct position of this 23, so it will be 9. It will be at the position of 29. 23 will be at the position 29. So answer will be 9. Okay. Here this is again a problem of max heap. So again we can just implement that will. Okay. And guys, uh, a three array max heap is like a binary max heap, but instead of 2 children there are 3 children. I hope that all of you know this. Okay. For to represent that, we basically represent it by a array. Okay. The root is stored in a first location, which is a0, and then the nodes of the next level are then from a1 to a3. Okay. This is the nodes of the next level. Okay. Then the nodes of the second level will be stored from a4. This is how basically we store it. So if item x can be inserted into the array, okay, so we can just push it into that heap. Okay. So it is asking what is the valid sequence of elements in an array. Okay. This is what it is saying. So guys, the thing is that the point which is given to you, as I told you, that it is a max heap. Okay. It is a max heap. As I already told you that it is a max heap which is given to you. Okay. So obviously the first element should be the maximum one. Okay. Because first is a root element. So first should be maximum. So this one is discarded. This particular is discarded. So answer should be this or maybe none of them. Now the next will be again, because we have to take the children's. Okay. So the next should be something. So basically the thing is that if we have a particular node, so the next three children's, or basically the next three elements of the after that node will be the children of that node. Okay. And all the values after that should be less than that. So you can see here in this case, this is 775. Okay, it is possible, but after this 5, this 8 is there. So if this 775 is in the first level, then how 8 can be in the second level? Because it is a max heap. It is not possible. And this particular way, you can see it is possible. It is totally possible. If we will just create a max heap tree from here, 10 will be the root, then 7, 8 and 5 will be the next uh, child components, child elements, and then 4 and 3 are there. Okay, this is how we can solve it. Okay guys, this is again a straightforward problem that you that there's a following post-fixed expression with single digit operands and is evaluated using the stack. Okay, so this is what we have to do. So it is a postfix. So all the so first we have to convert it into a infix operation. Okay. So if anyone who has any problem in this conversion to infix, just you can ask me. I can also explain that thing. Okay. And if we talk about the answer for this will be 24. 24 is the answer for this given problem. Okay. Great guys. Great. Here this is the XOR operator. Okay. So this is so you can see that we are using bitwise operators because it is also in your syllabus. So here we So we are given with, so we are taking a circular queue which can accommodate maximum of 6 elements. Okay, we can just take 6 elements. So front is 2, rear is 4 in this case. So queue is something like this. Okay, what will happen if a DQ operation takes place? So it is asking that what will happen if a DQ operation will take place. That what will the value of front, rear, and how our queue will look like. That is what we will do. So because we are making a DQ operation, okay, so our front element will be basically DQ'd, and the value of our front now become 3. So now the value of this front will become 3, okay, and this will be gone. So it will be something like mn, yeah, and front will be 3. So this will be the answer. Okay. Now the last one. Okay. Again, this is a quite recursive problem. Okay. So if y is 0, we are returning 0. Else we are returning x plus fun of x comma y minus 1. So guys, this is something which you have to understand, that the thing is that if y is 0, then it is returning 0. Otherwise, it is again calling it for x minus y minus x comma y minus 1. So basically, this fun function will be called y times, because y is decreasing by 1. It is just like a loop of y from 1 to y. Okay, and because we are adding x, how many times? Y times. We are adding x how many times? Okay, we are adding x y times. So what will be the answer? So answer will be x into y. For example, if you are adding 5 10 times, if you are adding 5 10 times, 5 plus 5 plus 5 plus 5 plus 5 10 times, so the overall you will get 5 into 10 50. So similarly for this, answer will be x into y. Got it? So these were the quiz MCQ problems. Now let's move towards the coding problems. So first we will discuss this balanced problem. Okay, so this problem is quite interesting one. Okay, where we are given with Alex is the head of the country, and he notices that some people in the country are becoming too rich. Okay, guys, am I audible now? Sorry for that. Maybe there was a issue. Am I audible now? Okay. Fine, fine, fine. Okay, great, great, guys. Yeah, sorry for that. So now what we can do? So just guys, this is a quite interesting problem. Okay, so just try to understand it. Okay, because there are quite observations behind this. The implementation is not so difficult, but the problem is really interesting. Okay, fine. Okay, so let's move towards again to the problem part. So what we are doing, that either we can increase the value of the whole array by +1, or then we can take a sub array from 1 to x and decrease it by 1, or either take a array from x to n and decrease it by 1. Okay, this is what we can do. This is what we can do. Okay, great, great. Also guys, what we have to do is that at the last we want that all the people of this particular country should have the same amount. So this array should be basically equal. Okay, so it means the difference between the poor and rich is equal. Basically, this is what it is asking. So basically, we are making it equal to a value a. So all the elements are a. Okay, this is what we have to also consider. That what should be the a, what should be the value of this to solve this given problem. Okay, guys, great. So this is something how which we have to observe. Okay, so in this case, can anyone tell me that what is the approach one has followed to solve this problem? For this problem, what we will do, that we will take two pointers. One will be the left pointer and other will be the another will be the right pointer. Okay, and one will also be the last pointer. Okay, so the last pointer will basically will start from the zero index. Okay, so the case will be that we will add the value of right to our index, to our element. Let me just first write the code, and then I will try. Okay, then I will try to make a dry run to explain that code to you guys. Okay, to explain that code to you guys. Okay, so first let me just solve that question for you, and then while solving the problems I will explain a dry run, so because it will be more easy for you guys to basically just confirm, guys. Am I audible clearly now? Okay, okay, okay. So yeah, okay. So now what we will do now, that we will first code this thing. Okay, we will first code this thing, and then while making the solution we will try to understand a dry run. Okay, we'll try to understand a dry run, how it is basically what we are implementing. Okay guys, so just focus on the logic, don't focus on sir what you are doing, why you are taking so many pointers. Just focus that how I am thinking and how you have to think to solve this given problem. Okay, great guys. Okay, yeah, so let me just start. So first what we will do is that we will take some iterators. So because we have to find the cost. Okay, we have to find the total number of operations basically, that may be the cost or something like that. Okay, that is what we have to do. So for that we can take two variables. It is cost, it will be 0. Okay, also along with this we will take two more pointers which will be left and right. Okay, along with that we will also take a last pointer. So this will basically store the value, because we are basically iterating from we will basically iterate from our array. So this last will store the value of the last element where we are. Okay, this left and right are basically two pointers. I will tell you how we will store the values there. And this cost is basically the cost which we will find. Okay, the cost is basically the cost is, let me just tell you that what is the cost. Okay, let me just explain you. Fine. So for example, our current element is 5. Okay, this is our current element, and I am telling you that change this element 5 to 3. So can anyone tell me that what will be the cost required to change from this 5 to 3? So the cost will be 2. Means we have to make at least 2 decrement from this 5 to 3. So the cost will be 2. So this will be the cost basically. This is how we will solve. Okay. And this left will store the left element, right will store the right element. Okay. Fine. Now what we will do? Now we will just iterate from the array. Okay. This is what we will do. Then obviously we will just implement that in our element. We will first add the right element. So currently right is 0, because for this I is equal to 0, currently right will be 0. Okay. Also, just a second, because for this I, when I will be equal to 0, when I will be equal to 0, in that case there is no last element, because we have not traversed to any element, na. That is the first element only. So in that case we will make our last is equal to ai, means a0. A0. Oh sorry, you will say that what is a? I am taking this array as a. Okay, this array people as a. We can take it as a or any name. Fine, great. And if I is not equal to 0, in that case we are doing it like this. Else we are doing it like here. Okay, got it, great. Guys. Just I want a chat from your side if there is any doubt. Okay, if there is any doubt. Otherwise we are adding this right here. Okay, fine. Now what we are doing, that if our ai will be equal to last, then we will continue. Now you will ask that, sir, why we will continue? Because our ai will become equal to last when we are at the first element, you can see here. Okay, and for the only that first element we cannot do that, we cannot check for that. Okay, for the first element we cannot do it. Fine. Now because for this element, the thing is that basically we are comparing this current element with the last element. In the next step we will compare that. So if it is already equal, so we cannot compare, na. In that case we will just continue. Otherwise we will compare. The comparison will be that if ai we will less than last, if ai will be less than, this is the first comparison. In that case what we will do is, in that case we will make a thing that we will add that value to the cost. Because what we are trying, we are making to change the value of this ai to this last. Getting or not? We are trying, for example, our ai is, let's say our ai is 5, and we have to change its value to last, and let's say last is 7. So it will require two operations, two costs to change. Okay, that is why we are adding it to the cost. And if we have changed it, when we have changed it, now our last will also be updated. Now our last will also be updated. I hope that this is the simple if else statement. This is a simple if else statement. Okay, great. Now if we will move towards the else part. Now we will move towards the else part. Okay, how our else part is basically working. Okay, Sure. Fine, guys. Fine, fine. Okay. Now for this else part, what we will do, we will again check that the last thing was that our AI was less than last. Now the thing is that our AI is greater than last because it cannot be equal. If it is equal, then it is just continued. So if it is less than last, okay, in that case we don't have to do anything. We have to just make two changes in this statement. The cost will be as it is. Just the change will be that here we are making this cost plus last minus AI because last was greater. Here we are making AI minus last because AI is greater in this case. Okay, and because we are changing last to AI, in this case we are changing the value of AI. That is the algorithm. That is the observation you have to make. Okay, that is the observation you have to make. And the value of right, this is the case where the role of right is there. Here is the role of right variable is there. Okay, great. So guys, what will happen now, that in this AI we will also have the final value. In this AI we will have the final value. And if the last, this last will basically store the last element which we will take. If this last will be not equal to the final value, then we will also add into the cost. Let me just tell you that after iterating from this array, from this for loop, what we will do, we will make our cost, okay, plus is equal to abs of a and minus 1. Why I am doing this is, okay, because for the last element we are not checking, so we are just adding it to the abs to our cost. Okay, because that is the last element. Fine. And the case, there is also a case that if, so here we are assuming that our last element should be equal to the a of n minus 1, means our last element should be equal to this last variable which we are taking. Okay, for all the details for the top 100 we will just notify. Don't worry uh, about the verification or anything. Okay, we'll just update it, just that thing. Fine. So if our last will not be equal to a of n minus 1, in this case we will make our cost is equal to, okay, in this case we will just update our cost once more. In this case our cost will be added with the value of abs cost, right? Okay, this will be the case. So guys, if you have any doubt, because I think that many of you have doubt in the sample cases also and other cases also, so in that case you can just try run this code by your own also. I have explained this, how we are doing, how this cost work is managing, how this all thing is, how this all stuff is basically doing here. Okay, so this is what we can do. This is how we can just do this particular problem. Okay, yeah, fine, great. The next problem was again an interesting problem. Okay, so the problem is that we are dealing with n people standing in a queue for the bus. Every ith person has an age I. Okay, if the person becomes unhappy, if there's a it will become unhappy if there's a person whose age is less than him and is standing before him. Okay, the unhappiness of ith person is a number of people standing between him and the youngest person. Okay, that is what it is saying. Fine. So yeah, we will understand this thing in the whiteboard too, that how we are solving this problem, how we are doing it. Okay, so let's copy this test case. Okay, and for each test case we will check that how we are solving and how we are finding our answer. Okay, that is what we will do and that is what we will find. Okay, yeah, just a minute, let me just share that whiteboard with you guys. Yeah, now if anyone has any doubt you can just ask, no problem, you can just ask it here only. Great, guys, great. So the case which was given to us was something like sample case was like, yeah, yeah. So we will discuss the sample case which is given to us in the sample of this problem. Okay. Uh, Let me just check. It is 6 that we are given with a 6 person, and the values were 10, 8, 5, 3, 50, and 45. Okay. So these were the values which were given to us, and we will just solve our problem for these given values. Okay. Let's see that how we can solve this. Okay. So the problem was that the unhappiness of a person is the people standing between him and the youngest person. Okay. And the youngest person. So okay, so if, so let's say that here for this 10, okay, for this 10, or you can say for this 8 or for this 45. So if a person is happy, then the answer is minus 1. That is also a case. If someone is happy, then the answer is minus 1. Okay. So fine. So for this 45, you can see that there is no one after him. So it is obviously minus 1. Okay. Fine. Fine. Now for this 50, the next youngest person is 45, and there is no person between them. There's no person between them. So the answer is 0. You can see that there is no person between 50 and 45. So answer is 0. Similarly, for this 3, again the answer is minus 1 because 3 is the youngest. There is no one which is less than 3 after 3. For this 5, answer will be again 0 because 3 is less than 5 and there is no one between 3 and 5. So the answer will be 0 because we have to tell the number of people standing between the person and the youngest person. Now for 5, it is bit that for 5 the youngest person is 3, and between 8 and 3 there is a 5 present, means there is one person present. So answer will be 1 for this. And for this 10 again, the youngest person is 3. For this 10 again, if I will just erase all these things. So for this 10 again, the youngest person is 3. Okay. So the answer will be 2. Why 2? Because there are 2 people between them. I hope that problem statement is clear. I hope that everyone has clear with the problem statement. Is it clear, guys? Just tell me. Okay. Great, great. Okay. Okay. Fine, fine. Sure. So now we can just move towards the code part. Okay. If this problem is clear. So for that code part, what we will do, guys, that let me just explain this problem to you, that how we will implement the logic. Okay. So the logic will be something like that. We will use the minimum suffix array. We will create a minimum suffix array. So minimum suffix array basically, it means that we will take the suffix array till a particular index, and we will store, then we will store the minimum of all that values, the minimum of all that values. The answer, Marcos, the answer for this case which is I have explained is given to you, and if you want to check any other test case, so I will just explain the code after this explanation. You can just try that code, you can just implement that code by yourself, and then you can find the answer for this test case. Okay. Yeah. First let's discuss the code. Then also if you will have any doubt, surely we can find this. Okay. Surely. Okay. uh, no, I don't think that it will be wrong because many of you have also submitted this problem correctly. Okay. Just try it. Maybe you are getting some mistake, some hidden mistakes are there. Okay. Yeah. So for this now we will find a suffix array. It is like minimum suffix array. So till this index, array is 45. So the minimum of 45 is 45 itself. Okay. It is 45 itself. Now we'll take suffix array till index number n minus 2. So again the minimum is 45. Not till here, the minimum is 3. Not till here, the minimum is 3 again. Till here, again the minimum is 3. Until this index, again the minimum is 3. So this is the minimum suffix array. 3, 3, 3, 3, 45, 45. Okay, this is what we will do. Getting? This is what we will do. Now for each number we will find its next younger, or you can say the younger element, the younger person. Okay, okay. Why? The thing is that for this 10, obviously we have to search for this 3. For this 8 also we have to search for this 3. Why? Because using this suffix array, we have got that what is the next younger element from this 8, which is 3. So this, why we have, you will ask us, sir, why we are calculating this suffix array? We are calculating this suffix array to just find that what is the next younger element. So because you can see that for 10 it is 3, for 8 it is 3, for 5 it is 3, for 3 it is 3 itself, for 50 the younger is 45, you can see, and for 45 again the younger is 45 itself. Fine, great. So now, and then by using the binary search technique, we can easily find the index of this 3 too, and then we can just output the difference between this index of 3 and index of 8, or anything, like index of the given current element and the element in that suffix array. We can just find its difference. For example, if we take 10, so the index of 10 is 0. If we take 3, so index of 3 is 3. So we can just subtract, it will be 2. And for 10, you can see that 2 was the answer also. Similarly, for this 45, or let's say for this 50, the next younger of 45. So index for 50 was 4. Index for 45 was 5. So we'll just make 5 minus 4 minus 1. It will be 0. And you can see that for 50 the answer was 0. This is how we will just solve it. Okay. Yeah. This is how we will just solve it. Okay, guys. Great. 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 Now let's move towards the code part, how we can code this particular logic which we have got. Fine. So first, as I discussed, we will first take a array of suffix that will be of size n only, and also we'll take a vector answer where we have to store the answer, that will be of also size n. Okay, this is what we will first do. Yeah, then what we will do, that obviously the last element of our suffix will be as it is, the last element of the age which is given to us. Let's make this age to v, that will be easy to write. Okay, great. Okay, this is what is we have. Okay, now to find the suffix, I'm just telling you a very basic technique how we can calculate this suffix minimum suffix array. It will be something like this. Okay, Marcos, just go through again. I have explained the whole problem. Okay, just go through it, and also I'm writing the code. First, please focus on this code. I am sure that you will get the problem after this. Okay. So here, this is how we are finding that suffix I will minimum of suffix I plus 1 and vi. This is how we are finding, we are taking the suffix. Okay, just like we find prefix sum and prefix, similarly we are applying from suffix, and for suffix we are iterating from back to front of the array, from back side. Okay, great. Now the thing is that we need an answer vector. Okay, we need an answer vector. So that is what we have taken already. Sorry, we have already taken this answer to store. Okay, so now again we will iterate from the front. So as we all know that now this suffix array is basically having the next younger element from where we have to calculate distance. That is what it is having. Okay, so this is I. Okay, so for that, this suffix, let's take y. So y will basically the suffix of this I. So as I discussed that for this 10, in this case, the for this 10, the suffix I will store 3. And then we have to find a difference between this 10 and 3. The distance between this 10 and 3. That is what we have to find. Getting? And that can be found, that we can be found using a binary search function. So we can just write another function, which is something like you can distance function, okay, which is similar to the lower bound implementation, okay, and we will use binary search technique there. Uh, so let's write that function that will return a distance. So it will return int. Let's name it this. Okay. It will take nothing. It will just take a vector and similarly array. So because we are storing this suffix in an array, so let's take a array here. Okay, it will take a array and the size of the array, which will be n, and a number, which is y in this case, because we have to find the distance between that element to this number y. Okay, this is what we have to find. Great. Basically, here what we are doing now, here we are just finding the index of this y. Here we're finding just like the index of this 3 is 4 here, sorry, 3 here. Index of this 5 is 2 here. This is where we are finding index. Okay, but from this suffix array. Fine. So we can just implement this function. So this function will quite similar to the function which we apply for binary search, Okay, this will be the case. And then what we will do, we'll just apply that while our high will be greater than low, because that is the case. No, that is the case. Our high will be greater than low. Yeah, exactly. Index of youngest person minus current index minus 1. Exactly, Marcos. This is what we have to do. This is what we have to do. So while low is less than high, or less than equal to. Okay. And what we will do, then we will also take its mid. Okay. We will also take its mid. And then after taking its mid, we will implement the two conditions here. So the two conditions is that if x is less than if x is less than this case, so we are just making high is equal. This is just like a binary search implementation. Okay. No, the thing is, Marcos, that yeah, we can use inbuilt functions too. We can use the total, but here I'm using it because I want you guys to learn that how we can apply lower bound in this way. I know that this is quite more difficult, but I want you guys, because everyone can solve it in an easy way. Okay, that is okay, but because I want that you can also know this method too. Okay, that is why I'm saying to you. Fine. Yeah. Okay. Great. Great, guys. Great. I hope that you all are getting this, that how I am implementing. And also we have to check for the we have to also check for the uh, corner cases. So the corner cases will be uh, here. Let's take it small n, because we have taken a small n now. So corner cases that maybe a low will be less than n, or the value of ARR low will be less than y. That is also not there. So in that case, we will increase the value of low, and then we are just regarding the value of low. Okay. So here we have found a distance. So let's implement it here and call that function here. So that function will be called here, and let's store that value in x, a variable x. So it and x will be equal to basically distance of ARR comma n comma y. Okay, great. Sorry, here we will just implement. It will be y, because we can just find an index from y or from this also. Sure, we can do this. And then again, the same will be there. The case will be same, that if the index x which we have founded is less than the I. Okay, in this case we will just output -1, means there is no number which is means basically the person is happy. So if the person is happy, we have to just make -1, else we have to implement the logic. Okay, and after doing this, we can just return the value of our answer. Okay, this is what we have to do. There was Sorry guys, sorry, here it should be suffix. I've taken ARR. That is just small mistakes. Okay, okay, okay. What happened here now? Okay, sorry. Yeah, I hope that now it will work. It will work. There were some small errors. Uh, just a minute, guys. Just a minute. Just wanted to check. Yeah, it is fine. We are just making this I plus plus. Okay, here it should be x because now we are taking this variable as x. Okay, I've just changed the this particular variable to x. Okay, yeah, yeah, guys, please go to the question. Just focus on the question first. Okay, I think that will be good for you guys. Uh, great, 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 great. So this is how guys we basically solve this given problem. Okay, and I hope that you all have got this fine. Uh, these were the cases and that were the answer fine. So fine guys, you can just check out this code. Okay, you can just check out this code, and if you have any doubt in this code you can just ask me. I am there only. Fine. Yeah, if you have any doubt in any case, anyone of has any doubt, you can just ask me. I'm sorry, there were some changes. Great, 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 great. Fine, fine. Okay. You can just yes, sure, I can just submit. No problem. No problem. No problem. There was some. Okay, you can just submit. Fine. It has got. Okay. Fine. 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 So I hope that you have got this problem. I have submitted this problem. Fine, and it has got the right answer. Fine, guys. So okay, that was all for today's stream. I hope that you all have got. Uh, okay, okay, Marcos. Let me just take your output, your custom output. You are saying that take 7 and 10, then 4, then 6, then 3, then 2, then 8, and 15. This is what you are saying, na? 15. Okay, sorry, it's not 14, it is 15. Let's check. After this, we will just conclude this session. It is already over time. Yeah, so this will be the answer, Marcos. You can check, okay, and also you can just code this by your old self, and then also you can get it, okay. Also, guys, if you also register for the next Biwizard contest, okay, which is Biwizard 6.0. Just register for that. Link is pinned in the comment section and also in the description box. You can just register for that also. Marcos, I think that you have not got the problem clearly. Just first go and read the problem again, the problem statement, and then implement the logic which I have discussed. Okay. Then you can just check this. Okay. Yeah. Great. Uh, why I'm returning list? It is showing integer. Uh, yeah, it is basically it is returning integer because it is something like for that question only it is returning integer, okay. Otherwise it is also returning string, okay. There are some cases it is basically the way how it is how the compiler is doing work na. Your work is to give a right solution, okay. Your work is to give the right, that compiler side work, how it is working, how it is checking your code, that is compilers, fine. Okay, guys, I hope you have got this. Thank you for joining. Thank you.